I'm focused on DX. Like all my libraries are basically focused on it. And I do have a motto, which is like I like to fight TS so others don't have to. Like my whole goal is to I'm usually working in teams, and I like to use inference as much as I can, So like I don't like to open a project and have like all these type definitions for simple things. So wherever we can use inference, yeah, that's where I like to act.
So welcome everyone. Today we have StringTs. StringTs is a pretty cool project. I saw it. I think Guga, you dropped it in Matt Pocock's Discord is where I first saw it anyway. But
yeah. But actually,
how about you, David?
Yeah,
he posted
I
something
saw it there. It might have been after
I
saw it after he reposted it on Twitter or whatever it was. I feel like Dimitri is kind of like, name dropping whatever. He's like, oh, I was one of the original people who saw it before it got big.
Oh, really? I don't know. Okay, so I actually don't know if that was before or after. I don't pay much attention. Matt's Discord is like just about the only one that I like actually look at from time to time. No offense to everybody else. I know, David, the ArkType Discord is super cool. Actually, I do check in sometime. Anywho, we're here today to talk about StringTs. Guga, I mean, we're going to jump in a second, and I'd like you to introduce yourself, but just to make it more streamlined, David, could you introduce yourself first?
Yeah, my name is David Blass. I'm working on ArkType. It's a validation library that parses TypeScript syntax.
Yeah, so I'm Gustavo, known as Guga. I work as staff engineer at House Numbers, a startup, but on my free time I do some open source endeavors, and yeah, StringTs is one of them.
So tell us about it. I mean, how did you get the idea? Where did this all come from to make StringTs? Okay,
so I do have other libraries, and I'm always trying to have very low-level primitives, and like my sort of library is a very low level that I like to extract, and then from one library extract another library, and that's what happened. I started doing some string transformations in the make service library. You guys, I'm not sure if you're seeing my screen, but yeah, that doesn't matter right now. And I was working on this make service library, and which is basically a wrapper around fetch to do some type safe validation with Zod, and it's similar to one library that Matt Pocock has, which I think it's Zod fetch, but it does other stuff. And then at some point I needed to transform the payloads, because I usually work with APIs. Actually, in the past I used to work with APIs built on Ruby on Rails, and they are all snake cased. While in JavaScript, we like to transform things to camel case and work with it, and then transform back again to snake case to send payloads. So it all started there. I wanted to do that transformation at both runtime level and also type level. And then I created these functions. And it was like a crazy adventure to do that. And I got very excited about it, and then I decided to like build more strongly typed string utilities because I was having a lot of fun with it. And so I started to find like other use cases for it, and yeah, that's how it started.
You got addicted. All right.
Yeah, addicted.
I've seen this story before.
Yeah, I love doing type level programming, because you're so it's so powerful, and yet you're so limited to like the functional programming mindset, which is what I love. And then, yeah, once you start doing it, it's pretty addictive.
Aren't there other things out there that can do? Well, show us what it can do, because that's always the first question is like, what is different about StringTs compared to, well, there are lots of things that are sort of in the same ballpark, right?
Yeah, like TS to belt, I'd say typefast. I didn't research a lot, so there might be other libraries doing something similar. And that's one of the reasons I firstly sent the library to Matt, because I met him at the RemixConf last year. And then he shared, and it seemed like there was no other library that was doing like the exact same. So basically here in this GIF, I never know how to pronounce it.
Wait, let's take a vote. Okay, David, where
How
are
do you
you?
guys do it? GIF.
I'm
okay.
GIF as well. Okay.
Unanimous.
Blow us up in the comments if you did. Anyway.
Yeah.
I do want to say I appreciate the style of this like intro. I feel like when you go to the ArkType repo, there's also a GIF that looks quite similar in that position. I think it's effective. It like kind of draws you in. It's good. I know the only thing is there's like so many configs that a lot of time when you first go to the page, you have to like scroll down. That's the big challenge with JS and having a billion things at the root of your repo. So.
Yeah, I love the GIF presentations. And I think the first place I've seen it was PRPC's repo. And then I started adopting it and using all my libraries.
That's great.
Because, it shows like the DX, and I'm focused on DX. Like all my libraries are basically focused on it. And I do have a motto, which is like I like to fight TS so others don't have to. Like my whole goal is to I'm usually working in teams, and I like to use inference as much as I can, so like I don't like to open a project and have like all these type definitions for simple things. So wherever we can use inference, that's where I like to act. And so
walk
this
us
GIF.
walk us through this one.
Go. Yeah. So basically, I put on this GIF after Matt posted on his Twitter, because one of the reasons I got like so many stars in such a little time.
Oh wow!
Was because it was it's a lot. Like I would never say it would get that popular, but one of the reasons is because it was very polemic. People like polemic things, and so I put on that to show people, because people were not getting it. Like people were like, why would you import a library to do something that's native in JavaScript? It's pretty much like the current polemic of the Next.js conf, that there is this slide where Sam is showing like the SQL in the component, and everyone is talking about it because people didn't get like the point of it. And I think that's what happened here. So I put on this GIF to show this last line of code, which is like the inference of the result. And just to show people that every time you use a native function, you lose the type inference. Like here, I'm using 2 uppercase, and then the result is inferred as string. So then you bring the 2 uppercase from the library, and it's gonna infer the proper type, right? So that's basically what this code is doing. And now I'm going to do also a transformation, which was like the first use case I found about it, which is like using the deep camel keys here. And then your code is going to ask for the camel case version.
That's awesome. So it's really 2 demos in one on the page here. First to make the camel case, and then to join the string. So I want to ask you, because whenever we have content on Michigan TypeScript that it's like sort of like this kind of stuff, there's always a small group of people who wonder, why in the world would you need result to be anything more specific than string? What would you say to those people, or what do you think the use case is for having John Doe be like a literal string be the type of result?
Yeah, like the best use case I've ever found was like the payload scenario, right? Because you're probably gonna be asserting your payload with something at like ArkType. Not gonna say that. I usually use that, but I didn't check ArkType. Didn't use it yet. But
that's okay.
You're probably gonna
be used
doing...
the Discord, so you guys are both in the dumpster.
Both in the same group. But I shall. And you're probably going to be doing that, right? We do that a lot in the place I work, like checking runtime type checking, I would say. So you do that when you are playing with some sort of external interface, be there an end file or an API. And then that file might follow a different string conversion, like an end file will follow like the constant case, right? Snake constant case, not sure how to call that. And you're probably gonna be working with it in camel case, and you wanna do that probably.
The funniest name I've heard for that is Screaming Snake Case.
Screaming Snake Case, yeah.
I mean, it's awful. It makes you really not want to use it.
Actually, after getting involved with StringTs, I've seen a lot of different versions, and I'm feeling slightly more confident about how to call it. But there's other cases like you might be in your code, you might have like roles, like admin, user, or maybe when playing with like a React state, instead of having Boolean states, you're gonna have status states like idle, loading, ready, and then you're coding with string literals, and it bothered me that every time you run those literals through some string transformation, you just lose that information, So just by thinking about it, there's a lot of use cases, and the funny thing was like when this polemic started, there was a lot of great replies, and one of them being from David on why to use it and how performant it can be, and so one of the things I liked the most about this polemic was like getting to know a lot of people and other people kind of defending the purpose of the library,
Yeah, totally. It's nice to get it out there and get people's perspective, and in your case, even nicer that people have mostly good things to say, I think.
Yeah.
So you said you have a demo ready?
Yeah, actually, I set up this beautiful remix app. And
wonderful.
Yeah.
Love it.
And basically, I didn't prepare much before this call, but I was just sort of replicating the same code from the demo I was showing. And then also here I do have like the make service library, and just to show you like what was my first use case. So basically this make service is like whenever you're interacting with an external library, you can like create this object. You can set up some like base headers, like content type or authentication and stuff, and then you call like the API through like the methods, give it the path, and then you have the response. That's a plain response, like a plain native response, but it's augmented because it's called the typed response. If you just try to await JSON, this is gonna be unknown instead of any, and then you can typecast it here, like foo. Or you can give it, and then it's going to be inferred as that, but that's not what we want probably. And then you can give it like an actual schema, and that's a Zod schema, sorry.
With
David.
Zod, yeah.
And yeah, basically it's going to infer because of Zod, you're going to know like the inference of it. And that was my first use case. I wanted to like, I actually had linters to tell me this was wrong, So I needed to work with I needed to deactivate the linters, or I needed to work with camel case. And then it all started. Where's the StringTs here? Like deep camel keys was my first ever transformation called Zod transform, camel keys, and then.
Oh, so this is kind of baked into Zod, not baked into, but it's like a expansion pack for Zod.
What exactly?
Show me on line 26. What's going on with .transform?
Oh yeah, that's baked into Zod. Yeah, like you're first gonna check the schema and then you can transform it. Same thing as you could just run this like wrap this data here. Yeah, it's gonna be like the same thing. And
got it.
Now you're gonna have like the JSONified called test. And the whole point is like having the runtime. Oh, my code's probably too small, right? You told me to increase my.
That's okay.
So the main goal of this library is to always have like the same type for both type level and runtime. You know, never be surprised. And the fun thing about it is that when I started doing that, I had to build a lot of little primitives inside the StringTs library. And what I tried to do in the StringTs library is to use like the same functions. It's actually, I'm going to show the StringTs code.
Yeah, show us.
A little bit.
You're a file tree on the right kind of guy, huh?
Too big, yeah. Yeah, of course. Otherwise, like the code's always going to be jumping. Yeah. And let's try camel case. No, let's try snake case. Snake case is a good one. Okay, so check what I tried to do here. I have the string, and then I want to run. I want to turn it to a snake case. So I'm first gonna run it through the delimiter case and like split the words and put like the underline there. And then I'm gonna make them all lowercase. That's how I build the snake case, right? So that's pretty much the same. You have the same code here and here. You're first doing the delimiter case, like the same parameters, the same arguments here, same generic parameters, right? And then you're gonna wrap it in lowercase. So that's like the mission of this library, you know, having a lot of very small primitives, and if you're gonna build more primitives, you're gonna try to build with these low-level primitives.
I love it.
Sounds familiar,
like
David.
Very reminiscent of the process building ArkType. When I first published anything about it, I remember I called it like the first isomorphic type system for TypeScript and JavaScript, and I was like, look, that's an isomorphic parser. And I was trying to like coin a new version of isomorphic that was like in the type system and at runtime, and the behavior is the same. And people were like, what do you mean isomorphic is about the server or something? So like it didn't work. I don't use that really anymore. But like I think that this idea of like implementing functionality in the same way in parallel between the type system and runtime is really powerful. I got to take a look at the library a little bit. It looks awesome, and I could kind of see that you were employing a similar technique there. I will say I differ slightly in terms of I have opted to abandon the caps case conventions for types so that my capitalization aligns with my runtime code, so I can like import snake case once, and I have like it looks even more one-to-one. But a lot of people hate me for that, so I would not necessarily recommend it unless you're ready for a lot of flaming. But you know, it's out there. You know, you could join the club with me if you want.
Yeah, I've been through a lot of flaming already. So
David, you're saying on line 7 in your code base, line 7, the S of snake case would be lowercase, but that means that you can import it once elsewhere. And when you use it as a function, you get the JavaScript version. And when you use it as a type, you get the TypeScript version.
Exactly. TypeScript is incredibly good at disambiguating types from values. I don't think there's any situation where they are ambiguous at all.
Classes.
So it's classes.
That's the one.
It knows like
classes.
what you're referring to, at least. I think type of blah is a very bizarre way to handle constructors and things like that, but it's besides the point. I feel like in general, TypeScript is very good. It can do crazy stuff as well. If you have namespaces, you can like access your types like, you know, namespace dot something, and then it really looks like you're using like a class. You can really like fake it. I tried really hard when I was first getting into this stuff, and like I went really deep. I was doing a lot like what you were doing, and I was like, I'm going to make this exactly one-to-one. And like, you know, okay, so I have a like parser class or whatever, or like a parser state. I'm doing like state dot something at runtime. I'm going to make a namespace and I'm going to call it state. And like, I'm going to do this and I'm going to make this code look identical between these two things, which is awesome. I don't spend that much time now. Like I try to keep them pretty parallel, but like I will say that I have loosened up my restrictions on that very slightly due to, you know, that takes a very long time to achieve perfect consistency. But I'm glad that I did it. You know, got a little bit of the code base that I always use for pictures. It's very pretty. So.
Yeah, exactly.
Yeah, actually, Guga, I wanted to ask you, like, so you said there's flame warring or flaming. I don't know what word to use, but like you've gotten some negative criticisms, or I guess there's only one kind of criticisms. But anyway, you've gotten some criticisms. What have those been?
Like playing vomit emoji for yeah,
with no explanation.
With no explanation and some
very productive.
But basically the vast majority of criticism was like from people didn't understand people who didn't understand like the purpose of the library. But I did get some other criticism on like if you try to, let's think about another function here, like to get the length of a string. Where is it? Like,
notoriously difficult.
Yeah, and we not so difficult if you do that. But then people like showing me that if you give a string to, like, I can actually show you here, result equals to length. So that's how it works, right? That's pretty.
But then you hit the recursion
basic
limit.
No, if you give it a string and then it's gonna give you one, and that's not. Yeah, that's not what we want. And of course, I'm gonna fix that. You know, and yeah, basically those the things it was criticized about can be fixed. But I just wanted to put it out there and see how people felt about it. And actually there's a PR to solve that. But then we got into some other stuff like the native, I'm not sure if we should call it native, native type utilities. The result here is not going to be string. It's going to be uppercase string, because if you go to the definition, it's actually calling like
intrinsic.
some native code. So
Crazy.
I'm not going to be able to replicate that behavior, you know? Yeah. Yeah.
It's like, it's a fake type. I mean, like, no offense to the TypeScript team or whatever, but like, you know, great, just do something useful, but like, you just like shoehorn this into your type system, like, you know, because you could have real types for it, but like, and it's a very practical thing to do. And I know TypeScript is a practical language, and I see why I did it. But as like a perfectionistic type system author, I'm like, you totally cheated, like intrinsic by my butt. Like, you just wrote a function. That's not a type. That's like that's a validator. That's nothing. Oh, but like, it's still useful.
Actually, can I show you what I think is the way? Can you go back to that, to the uppercase?
We should start.
If you scroll down.
We should start writing code like that and see what happens.
That's okay. I was going to say, have you guys seen, there's a type called this type, which is also, I think it's even worse than intrinsic. If it's, anyway, it doesn't matter. If it's possible for you to undo tab or undo your closed tab and go back.
And do my.
Or you could just do uppercase again, like you were. We'll find it.
This type.
Or you could, you could do this type. Yeah. So if you go to definition on that. This is also a type that the compiler has special knowledge of. But
this reminds me of the Flappy Bird implementation a little bit, where you're like, oh, it's like, it's this type. The name is this. So like, this is what I will do. But like, you know, most of TypeScript types are real. So.
Yeah, it's like, I think these are the 5. It's the 4 intrinsic ones, and then the one right under it here, this type, which it's like, if you read this, you would have no idea what it's doing or why.
At least they're all grouped together here. Someone's going to refactor it at some point.
So, okay, cool. Can we look at the split implementation? Because I'm curious what the limit is on the length of string implementation you have here is.
It's not hard to hit the limit. So every time I look at this implementation, I have to think about it again. And You want me to try to hit the limit?
It would be 100. Yeah. So this is going to recurse
100.
once per character. Do you agree, David?
Yep. Yes. I mean, that sounds reasonable to me.
Yeah. So basically, oops, copied too much code. Yeah, at some point we're gonna hit the limit.
I mean, we could see what the number is by using length, actually, right? Well, anyway, I was just curious. It's always interesting how many different ways there are to do some of these like extraordinarily simple things because they're extraordinarily difficult in TypeScript. Especially, does StringTs deal with arithmetic or numbers at any point?
Yes, it does. What's the name?
Show us something like that you think is fun.
Yeah,
oh boy.
Like absolute numbers, and of course I've got some inspiration. I had to do some research to do that. I'm not that crazy math addict, but I was able to.
I feel personally attacked.
Yeah, maybe I stole some of your code.
I actually no. I mean, I don't. I have not yet found like a use case for this type level math and like, you know, in my day-to-day work. I'm very lucky to have a use case for all this string stuff that I think is doing something, but like I have yet to find one where I'm like, yes, I need the math here.
You want to see the use case? It was ends with includes, because the problem about this type is like it has more arguments, like it takes more arguments than the string. You can give it like indexes, like a start index, end index, and then there's where like the craziness start, and you have to start using math. And so yeah, first just checking if the number is negative, and yeah, there's a lot to think about this code. But basically, the whole point of this thing here is to replicate as much as possible like the native utilities, even though sometimes they don't make sense. So we have to replicate that nonsense.
It's the same thing TypeScript is doing, basically.
Yeah, exactly. Yeah.
TypeScript for JavaScript now. I guess it's like supplemental to TypeScript sort of in some ways, but I'm curious if I know that this is something that people have mentioned. If you thought about and or experimented with having a like supplemental set of global definitions that would modify the way that string worked, or whether that's feasible or not, or what the like potential drawbacks of that might be.
Yeah, a lot of people requested that actually, and yeah, it's a dilemma for me because I don't know how I feel about it. There's the TS reset I tried to use in some projects, and some rules worked in my projects, but if you put too much rules in your code base, it's going to restrict a lot, and then it's going to be very easy to introduce some rules. So what I've been telling everyone is like, for every function we have in the library, we have the type level utility exported as well. So you can do your own reset with those. And yeah, I'm not sure if I want to get into that and like having, maybe if it's like very easy to have an alternative, I'll do it just because people asked. Otherwise, I think I'll just throw a FAQ and teach people how to do it. You know?
Yeah, it's tough. I mean, speaking of this particular function is I say function, but you know, type.
Yeah, this one.
We all know what I mean. So this particular guy here, I mean, how do you test something like this? How do you be sure that you don't break it by accident in the future?
Yeah, let's show you guys tests. So for every, actually, let's start with a simple one. Let's start with, title case maybe. So for every file, we have like the type level test, which just doing, it's just using expect and equal. You guys probably seen it a lot. And yes. I'm especially the string transform. I mean the casing transformations. I'm testing unions here because we had problems with that before. But
I was going to ask about that. That's a tough one.
Yeah, it's a tough one.
I think that was like one of the first problems I ran into with the parser that I remember that was really was very tricky to solve. And I think it's a little bit of a different scenario than the built-in methods, because when you're thinking about something like replace, if you like want to replace and then you do a union of possible like replace, sequences or whatever, you'd want to have the result be every member of that union substituted in to the original string and a union of those transformations essentially. But for example, like when I tried to take that kind of approach when I was writing the parser, it didn't work very well because I was like, okay, I want to know, for example, like what the next operator was. And, there might be an operator that's like less than, and there's another operator that's like less than or equal to. And so if you say like, we'll parse until the next operator, and then you get like two different results as you're iterating over a string, like you're kind of doomed at that point. Like you can't like have two different parse results. Like there has to be one thing that's correct and you have to disambiguate it. So then I ended up eventually switching to a parser that iterated over one character at a time instead of like looking for like if some delimiter occurs in a string, which eventually is like important, but probably maybe that's not like a requirement, I guess, for these kind of string transformations within JS. It's like more streamlined probably, hopefully.
Yeah. Yeah, we also ended up this whole library also has to do like character by character. But when we had problems with unions, casing, we found some solutions, but then it was later replaced by the thing I told you, like building very low-level primitives. And once I built other primitives and then I replaced the code to be like the one I showed you, this test kept green. So it just happened,
That's awesome.
So by building the lower level primitives,
that's really the way to do it. I want to commend you for that, because I do feel like a lot of people like doing, extreme stuff in TypeScript or whatever do just have this kind of mentality of like, I'm just going to like hack at it and get something to work. And like, wow, look at how complex my TypeScript type is. It's crazy, but like, it's also completely like unreadable and unmaintainable and unpredictable and unperformant. Yes. Like actually you really want to build it. Yes. You really want to build it the same way you'd write normal code. Like you want to split up your functions and split up your generic types and like name things accurately and, test the performance and yeah, like give it the same level of care, not just like, I'm just going to like hack something together until I get the console log that I want or something. Like it's like your CS 101, whatever. Like that's just, it's not going to work really. And like that, I think leads to some of the bad DX for libraries that have these like crazy types, but don't necessarily have like a ton of standards around how they test their types. But like, obviously you've put a ton of care into that, which is awesome to see.
Yeah. And also for every function here, then we're doing like the runtime tests, but I'm also testing like the type of result against the type of expected.
That's great. I feel like you should check out my testing library. I feel like you would probably love it, because you can do like assert like type assert type and value, so you can like do both at once. You can do like, this is a really big one that like I would not be able to like build a parser like this without. I don't know how much you use error messages and things, but like assert like throws and has type error to say that like it has to like throw a certain error with a certain string at runtime, and also there has to be a type error on that line that includes that text. So like doing stuff like those kind of utilities, I don't think that those like exist anywhere else that I've seen. But I guess like I don't know how many like parsing error scenarios there'd be if you're doing like JavaScript string manipulations. I don't know. Are there any scenarios in the library where you have like invalid input? Like if you could theoretically give someone some kind of like lint error or something or whatever, maybe if they pass in like a literal string with no delimiter character in it, that they pass in a delimiter like that doesn't exist in the string, you could be like, this will not do anything because like we know trivially that like this delimiter isn't contained in the string or something like that. Do you ever do any kind of like messages like that?
No. I don't do that.
It's probably crazy and overkill.
Yeah, I don't go as far as doing that, and that's the case with the that I showed about the length when people give it a string, and we're gonna change that code. We're gonna just assert for if it's a string. If string extends the parameter, then we're just going to return number instead of literal number. But
one other case you have to think about is like string template, a template literal that has string as one of its positions. Like since that string won't extend that, but then it will still be like X number of characters that will be number. So you'll have to, I have to look back at the best way to figure that one out. But yeah, you'd have to detect it somehow.
Yeah, there are so many ways to sort of break it and that's my dilemma. I don't feel like I want to cover all these cases, and that's one of the reasons I don't want to make TS reset scenario here where you like replace the whole TypeScript behavior, because I think I like to have like the utilities use them on demand for places where you're really working with literals and maybe taking responsibility on it over what to do with it, you know,
right?
And instead of being like too much, over controlling it, you know. And also because I like to keep the scope of my libraries like smaller, because once the scope starts to get bigger, it's pretty hard to maintain. And then we have David, who is like a full-time open source maintainer, right?
I don't have any problems with scope. Everything is fine. No issues. You know, very normal, very fine.
Speaking of which, I have an extremely shameless plug. What you're showing on the screen is exactly the use case for a thing that we put under the Michigan TypeScript org on GitHub. So there's this library we put out called type testing. And
bring it up.
It's for exactly what you're doing here, that sometimes there are situations when you want these expect and equals types. And the hope was to put them in one place and also write tests for them so people can see how they work and what they do. And there are not that many of them. It's not trying to be anything fancy. So David's library is much better, I think, in a way, because there's actually a kind of a provision at the bottom about that like, if you have something that can just build the type checking into your actual like regular expect function, then that's probably better. But of course, there are some times when you don't have an expect function because you're testing just types. So for situations when the types are the library, when like if your types broke, it's a big deal, then you kind of need to start writing tests for things. And I just love that you showed us your code base that is basically thank you for the star. I found a few examples, like if you go back for just one more second, like Zod, TanStack query, Zustan, TRPC, MUI, Typefest, TS reset, and the type challenges all copy exactly the same code over and over again. And the hope was to like put them in a place and document it so that when people see it for the first time, there's really nice long JS docs above it that explain what it is. It's like something people don't usually do. But anyway, did you copy this? I assume you have expect and equal as types in your own library.
Yes, I do. Yeah.
You can add it
and
to the
actually,
list.
how did I come? Copilot.
How'd you implement them? Yeah.
Copilot helped me with that because I was gonna start implementing it and Copilot just nailed it. And
you can just go to definition on them, right?
I'm trying to remember the name of the type. I think it's test.
But they're in front of you, right? So there you go.
Control left click though is like definitely a godsend. I feel like I use that so much to zoom around in my code base.
Yeah. So this implementation is probably popular,
it's the same.
right? Yeah.
Yes.
It is.
Yep.
So
the same one, but
yeah, I will say this is just totally random, but I was doing a what was it like? This is something in ArkType where it's some very complex thing where like extracting morphs from some inferred type, and I wanted to see if we knew that there were no morphs because the input and the output were the same. And in that case, like I would just give back the original type instead of type that got mapped over because people wanted the names of their types to be preserved or something like that. But like I did a test using the like that equals method and the like simpler equals method that's more intuitive, where you would just do like a two tuples and do A extends B and B extends A, which should be perfect theoretically. Like in TypeScript, that should be the answer to that question, but it is not exactly. But like ideally, that would work. But it's also most cases. And I will say that if you're worried about performance, and especially if you're passing in complex types, that equals is a lot worse for performance. So sometimes you need it. And for a type test, definitely you should just use the more accurate thing. I think that totally makes sense. But if you're ever like writing library code and wanting an equals, do consider like whether you really need those extra cases of accuracy, because they are pretty costly in terms of the TypeScript compiler. It does not like it as much.
Yeah, and that kind of sums up on what I was telling you. Like, I don't want to cover like too many cases on like my utilities, because then you're going to start going that route, like maybe performance-wise going to be slower, but also like the code's going to be like crazily complex.
Yeah. Yep.
It's a tough line to sort of toe. Do you have any particular functions that are, or any particular ones that you think are really cool and that you'd like to show? Like, what's your favorite type in the library? Maybe ask it that way.
I'm not sure this is my favorite one, but it's a base for all the casing transformations, right? It's because first you have to split the words, and then you do the transformations, right? So here I also try to do as much how did you call it?
Isomorphic parsing.
Isomorphic code as possible. And like the comments are helping a lot. Yeah, actually, when you said that, I thought it was a great idea, but then you said you left it behind.
I do think I sometimes still say it about the parser. I just don't use it to describe the whole project. But like the kind of nerds who are like really interested in how the parser is built and stuff maybe don't mind as much if I'm like branching out the terminology. They're more forgiving of that, or they'll object to it more fervently. It kind of depends on who it is, but yeah.
But anyway, this I'm trying to replicate like the same steps here. And of course, this is not like the most performant way to do it. Like the first version of the library had like one or two regular expressions here, but then I decided to just like follow the same steps on type level and runtime. And I've got some inspiration from other projects. I can't remember which one, maybe Typefast or TS2 Belt. But then I extended as a lot of other functions, like the math functions. There was one to sum or to subtract, and then
I think I actually
it doesn't
did
work
that
with negative.
That was the TypeScript type challenge that I did that Dimitri had me on for on YouTube.
Yeah. Subtract.
Yeah, subtract. And so yeah, I get some inspiration, but then sometimes I have to extend it somehow, and that's what I've done here, because the functions that you have in Typefast or TS2Bet, I never remember which one I firstly copied from. Yeah, but the transformations you have there, they are not the same transformations that people would expect at runtime level. And people are used to the Lodash transformations, right? So I tried to deviate a little bit from Lodash, but then people started complaining about it, and I just decided to follow the same Lodash pattern. And I had to translate that to type level. So yeah,
Wow.
Which makes this code quite unique, I'd say. It follows the same style, but it's unique in the sense that it's aligned with what Lodash gives you, right?
It looks really good. So one thing I'm curious about now that I'm considering it is like what percentage of the functionality in the library is like adding stronger types to things that string does natively versus what percentage is adding functionality like changing casing and things like that.
Let's try to infer it from the API.
So initially when I was thinking like, like for the native string stuff, if I had an option to like get the types like globally and it wouldn't affect runtime at all, like that does sound pretty good for the native strings, because if you could ever say like no runtime overhead, like that's definitely a nice thing to be able to like that's the ultimate library, right? Like how much does it affect my performance? None.
Yeah.
Like that's pretty good. But I suppose since you have like so many other methods as well, like that would only be part of the code base that you would be able to expose that way on string directly.
Yeah, exactly. And I try to categorize my
nice.
type
Wow.
of
Very well
functions here.
documented.
So these are like runtime counterparts of native type utilities. So you do have those in TypeScript already, but
great.
So it's just a wrapper that does the same at runtime. And then this is the list of the native functions that I've strongly typed. And there's also a roadmap. I'll open here the site. And these are all the functions, and I was trying to decide which ones I'll build, which ones I wouldn't, because it wouldn't make sense, or at type level, and there are still some questions here. People can vote or participate in the discussion. And then this is the list of the other utilities, like here you have words, truncate, and reverse, and other things that are not like native, and then also like the object key transformations, right? The camel keys and the deep camel keys and so on.
Documentation is great.
Wow.
I'm envious.
Yeah, the list of all the type utilities here, and yeah. There's a lot
that's
of
awesome. It's so funny that David asked a question and you had it like ready to go. It's all there. That's pretty great. Documentation is a very difficult part of all of this, isn't it?
It is.
That's really interesting. I've been meaning to ask you. Maybe you guys, one of you must know the answer to this question. So very quickly, I had a call a while ago with Ryan Kavanaugh and Daniel from the TypeScript team, and Ryan was talking about a new feature of TypeScript that they're thinking of building, and I guessed it, but he didn't want me to say it, so I bleeped it in the video. And then just to make a joke, I put it online and said, can anyone guess what the feature is they haven't implemented yet that, it's one that I really badly have wanted for many years. But I was surprised how often, I guess I'm giving a little bit away by saying it wasn't regex, but a lot of people messaged me and says, was it regex? Were they asking about regex? And so I want to ask you guys, why do people care? I don't want to say I've never hit the situation where I've thought, wow, I wish I could write a regex in TypeScript. Maybe I don't know any better and I've never thought about it, but why would somebody want something like that? Can you tell me?
Okay, we do have a use case here, but first of all, my guess to that thing was like higher kinded types. And
native higher kinded types.
Hope, I hope that's the...
I cannot have any reaction. Okay.
Interesting.
That would be awesome. Like, so awesome. So here,
wow, that'd be very powerful.
We have this replace and replace all. We cannot completely cover the functionality of replace, because you can give a replace a regex for a replace function. So what we do in the library, and this is also worth showing, is like we're gonna check. We're gonna return a string if it's not a string, right? If it's a regex, we're gonna return. So lookup can be a regex, and then if it's not a string, we just return string.
Have you seen David Ty built a type-safe regex parser? I'm quite keen on integrating something like that with ArkType. I think it'd be amazing, because it also ArkType does validation and stuff, right? So you could write regex, you could write it in a string. You'd have to write it in a string. You couldn't write native regex. We won't be able to get types out of that. But if you write your regex in a string, I've got an extension that does syntax highlighting, so it wouldn't be you want to tear your eyes out or whatever. And you could get validation errors as you're writing it, oh, you didn't close this group or whatever, at a type level, and then you could infer out the type of the regex as like a template literal string. If TypeScript added regex natively, that would make it a lot easier. But I will say that, like, you know, they're not going to do. I am very dubious that they would do a perfect job, which is fine. Again, they can do things practically, but like actually adding regex to your type system in a way that's like inferring as much accurate information as possible and reducing to like with template strings as accurately as possible would be extremely hard. And like I really want to work on that problem of like reducing regex intersections, but it is complicated. But like TypeScript doesn't even reduce like really basic like template literal expressions. For example, like if you intersect like S string with string T or something, so you should be able to infer like as a human that you then have like S string T. That's definitely true. But like if you compare those types in TypeScript, they like one is not assignable to the other. They don't actually, they're not like real types, almost like the intrinsic types in some way. Because like, to me, what makes something a type is that you can compare it to another type and like get an accurate result about whether that type is assignable or not.
Yeah.
So like TypeScript has this sort of like practical approach where there's a lot of things that they add to the type system that aren't like really like the type system doesn't really understand them, but it does something useful. And like honestly, like if the type system just like checked the regex, even if it couldn't reduce anything and like didn't really treat it as a type or reduce it with template literals, I mean, I would love that. I think that'd be great. Higher kind of types would also be really cool. So I'll be looking forward to when is it? Are you gonna like reveal this feature for them or something at some point, or are you gonna wait with our
not until the PR opens? I mean, like they got to start working on it first. I think it's interesting because I mean, I don't want to say one way or the other. I guess I already gave something away by saying it's not regex, but it was like extremely obvious to me what they were talking about from everything else before, and then I don't know, maybe not so much to everyone else, but.
Yeah, I mean, so I said you asked me, and I said exact properties, which to me that would be the number one thing in the language that like that is just like a killer.
My camera, I can't
for everyone.
I can't be on.
I feel like the number of times people complain about like iterating over keys in TypeScript, like it is genuinely really bad. Like just a bad developer experience. Everything gets widened to string, which like I understand the reasons, but like you need exact types so you can like mitigate that problem if you know there's not going to be extra keys. Like that would solve so many problems if they did that. Like I would love that.
Maybe you would both agree with this, but like the TypeScript that we're writing today, all of us, is pretty different from the TypeScript we were writing like even just 3-4 years ago. We're doing things these days like you have like Guga's library and David, your library. Like we have things that were almost inconceivable with the same TypeScript. Like if I gave you guys TypeScript 2.5 and said wait, which one had literal types? Well, anyway, if I gave you the version that launched literal types and type unions and said, make this stuff, you could get pretty far. But nobody was writing code like that in those days, even though the tool was able. We were all kind of figuring it out. So, well, I mean, in that light, actually, this is a good tee up for the next question. Where do you see this going in the future, Guga? Like, what do you think will be, like, a year from now, what do you think will be the state of this library, or hope?
Well, if they do support regular expressions at type level, I think we'll have to cover that. But my goal, I don't plan to be expanding much of the library, but just to achieve like the like not the perfection, but as perfect as possible in terms of having a very consistent results on either roles, like the type level role and runtime. Like if I can achieve that and cover all the string utilities that do make sense to have in TypeScript, that would be a win. And I think we're not far from it. I'm just wait people start using it and creating issues, collaborating, because I think we're gonna get there as much as TypeScript allow us. And I actually started building utility methods for things other than strings, and that I wish I could place somewhere. And I even reserved StrongTs package name because I thought about changing StringTs to StrongTs and then going further, but I'm not sure if I'm going to do that. Maybe I'm going to do that, but there might be.
That's such a great
package.
name. I'm surprised nobody had StrongTs before now.
Yeah. I feel like, I mean,
I can sell it.
I'm obviously pretty biased, but like I definitely see a lot of this kind of thing as, you know, the future of DX and TypeScript. Just that there's like so much untapped potential here, and that people just really don't understand how performant it can be, and you know that it can really make things drastically better. Like when you sort of refine it, and it does take like you hit a certain threshold where like before a certain point, it does kind of feel like, all right, it's like black magic and it's like unpredictable and like who knows. But you know, you can tell from the way that Guga's implemented this library that like you can break things down into like small deterministic chunks, and then like, you know, build those things up and compose them in predictable ways. Like that's extremely reliable. Like I think since I started building ArkType, like people ask a lot if it would like break when TS releases a new version. They're very conservative about the kinds of changes they make. But still, like it's doing a lot of complex stuff. Yeah. Like there was literally one instance where like updating TypeScript broke anything in ArkType, and it was a change that they then reverted like in a patch, you know, a few builds later. So like, you know, it's incredibly consistent. I think the people who are like, you know, oh, TypeScript is like, you know, when it updates, it like breaks my stuff. They're probably the people who like have those like crazy, they're just like intersecting a million things and just kind of like, it's like a hodgepodge. But like, you know, I think the like general takeaway is like, you know, write types that you can look at and like read and like explain why it's doing what it's doing. And if you can do that, then like it'll probably keep working, right? Like, whereas if you're kind of just relying on the fact that it happens to work, but like you don't really know why it works, then like, you know, TS might break that, and like, you know, it's hard to predict. But like, yeah, I think stuff like this has tons and tons of potential. So I'm really excited to see, like, I know there's been other stuff cropping up, like the GraphQL Mobius project doing like GraphQL parsing that's type safe, right? Like I think there's a lot of other kind of like these kind of approaches where like you can get a lot more type safety, and like I just think it really opens up a lot of potential, especially with those kind of like syntax driven like embedded languages and things where like normally you have some extra compiler step or something like that, but like if you can get the same DX you can get in your IDE plus everything else, it's really, I think there's tons of potential.
It's really an inspiration how clean the code is here. Like everything that you showed us, Guga, is like
totally
really reads well. And I mean,
pristine.
No matter what happens, it's cool that people that are building the next thing 5 years from now or 1 year from now are going to be building off of your shoulders, because this looks great. I mean, this is like you showed us. I don't know. I think it's pretty impressive what you put together here.
Definitely. Yeah, this is so clean. Yeah. Everything I've seen, you've like been so careful about everything. Honestly, like, you know, I am very particular about my design for like the way that stuff in ArkType works, but I would not claim that like every function that I've written is like certainly not as well documented. But like, no, that not everything is like as cleanly organized as this is. Like I think it's really very impressive. And if you want to see something, you know, really in the other direction, like I'm pretty sure Zod is like one file that's like 4,000 lines or something like that. So like it's probably pretty different. But like I love your approach.
ESBuild is one Go file, right? I think last time I checked anyway.
I don't understand. Or TypeScript, for example, right? Like I think the TypeScript code base is pretty good, but why is it all in one file? It's crazy, right? Have you ever asked them that? Do you know that?
Yeah, no, I would like to. That's a good question. I can ask them. I feel like that. How do you say that without being rude, though? But anybody who's wondering what we're talking about, in the TypeScript code base, just look up a file called checker.ts. And I don't think you can see it on GitHub because it's too many lines. It's one of those.
Yeah. I mean, I kind of assume there's like a reason for it. Like, I don't think it's just like, no, we hate like refactoring. We hate like, they refactored to ESM, right? Like they must have some reason why it is the way that it is. Maybe circular imports. That's something I run into a lot where like, if you build a type system, then like, you know, you have like recursive structures and you probably do need to have circular imports or like put a lot of stuff in one file. So I just try to like make sure the hoisting works such that the circular import won't be a problem. And then when I build it to be one file, but maybe they're just like, we're going to maintain it as one file. But yeah, it does seem pretty bad for like, if you have to edit it.
Yeah, I'm not.
These things just happen over time.
I'm not always like the one function per file kind of guy, but I was really concerned about tree shaking, and I also don't understand a lot about compilers, how they work. But I just thought that if I split every function in one file, it would help a lot. And it seems to have helped, as I could test already. Yeah.
Yeah. Plus, then you don't have to make decisions, which is great. Decisions are really hard and they're awful. Like, how do I group things together? It's arbitrary. You know, who knows? But if it's just one per file, then, you know, no decision made. You know, you don't have to worry about it.
Exactly. Yeah. Yeah, it's much easier. It's all about lower level everything.
Yeah.
Lower level primitives, lower level file structure. And yeah.
Yeah. That makes total sense. And I totally, your approach resonates with me very much of like, you know, you build up the smallest possible stuff that works. Like, you make sure that that's really concrete. And then from there, you just keep building on top of it. And then when people look at it and they're like, whoa, how does it do all this? But like every step is very predictable. And that's definitely the way to do it. So I think this looks great.
Yeah. And thanks, guy. I appreciate all the compliments coming from you both. That's awesome. Made my day.
You could put David on the list. I've never done anything. I copy pasted expect and equals into a library. That's what I did.
Yeah, never doesn't have any context on TypeScript. Has never seen any, you know, advanced. It just doesn't. No background.
A little bit. Is there anything we missed?
Anything we missed?
Yeah. You could say no.
Yeah, maybe. I don't know.
Cool.
I just wanted to thank you guys, and also like the contributors of my projects. I'm gonna just show their beautiful faces. Here it's a long README.
Nice.
Yeah,
I like having Matt on your contributor list is like a big win already. That's huge, you know?
Yeah, he opened a pull request, and then he tweeted the library, and then it went from 7 stars to 927. Yeah.
Awesome.
And hopefully after this podcast, we might reach the 1,000.
Well,
hopefully.
I don't know. We're not. Well, for anyone listening, you know, thank you for tuning in. We do
go start the project.
Viewership.
Make it count. Make your viewership count. Rep.
Yeah, exactly.
Yeah.
Go start the project. Wonderful. And yeah, Guga, thank you for coming on. And just like David has now, let us know in the comments below what you'd like to see in the future, everybody, and we can have Guga back. You know, we're trying to build, and I think we're getting pretty good at in terms of success at building a little community here of people who can look through this kind of stuff, and it's always fun to do. And anything is game. There's no library or project or blog post too small to be worthy. It's just like interesting stuff. That's all we care about. We don't care if you have how many Twitter followers you have or how many stars your library has. If you did something interesting, let us know. Everybody stands in equal footing here. So cool. With that, thank you very much for your time, everyone. And on to the next thing, huh?
Thank you, guys. Yeah, appreciate it.